All right, so the continuous function blah is defined from -6 to 5, and it shows you a portion. So it's defined from -6 to 5. This is a little tweak. It says it starts at -6, but what do you see? It starts at -2. So they're going to ask some questions about what happens from like -6 to -2. They just don't give you a picture, right? There's a portion. This is a quarter of a circle. They want to make sure that looks like a circle. No, that is a part of a circle with the center here. And you have this point, right? So, at this point, somehow I bet we're going to need, at this x value, we're going to need this weird y value. All right? So, everybody understand what they give you? And so now they start. And to be honest, this is the hardest version of this type of question I've seen. So if you have trouble answering it, it was clearly the hardest version of that I've seen. So they want to know what's the integral, if they tell you the integral from -6 to 5 of f of x is equal to 7, right? So they're basically telling you the net area from here to here is 7, right? What's the value from -6 to what's from here to here? And here's the idea. Anytime you've got like a big area, you can break that area up into different parts. Like I can say the integral from -6 to 5 is the integral from -6 to -2 of f of x plus the integral from -2 to 5 of f of x. Does everybody see how we broke that up? So they're telling us from here to here is 7. So we're going to break it up as the area from here to here plus the area from here to here. Now I don't know how to compute this, but I can compute this. And that's what I have to do. And so how do we compute, the area from -2 to 5? Well, I look at this and it's between the function and the x-axis, so this area and this area. Y'all see that these areas are going to cancel out? And as I continue, I've got this area and this area. Do you see that those areas cancel out? So if I want to know the area from here to here, I really just need to figure out the area from here to here. And the area from here to here is going to be comprised of this trapezoid. And you see it's like a square minus part of a circle?
Yes.
Right? So to find the area of this trapezoid, well, you could average of the bases times the height, but I don't like that. I look at this and I just like counting squares. Can we see that the area of this trapezoid is going to be 2 squares?
Yeah.
Because it's this thing plus this thing. So if I'm looking, I know this area is going to be a 2. And now to find this part, well, can we see it's going to be a square minus a quarter of a circle?
Yes.
So the square is going to be 9 minus whatever that circle is, and that's like the full circle. The first full circle will be 9 pi, so it'll be 9 pi over 4.
Yeah.
And so this is going to be 9 minus 9 pi over 4. And so now let's write down what we know.
But then it's 7 minus that, right?
Right. So here's what we know. This whole thing is 7. Yes, what?
How'd you get the 9 minus 9 pi over 4?
So I'm looking for this area. Do you see that this area is a square minus part of a circle?
Okay.
And so the area of that square is 3 times 3 is 9.
9.
And then the area of this circle is 9. Well, a full circle would be 9 pi, but I only want a fourth of it.
Okay.
So then I have 9 minus 9 pi over 4.
Okay.
And so now I know, they tell me the total area is 7. I don't know this thing, right? -6 to -2 of f of x plus, and this is 11 minus 9 pi over 4. So to solve for this, I'm just going to subtract. I'm going to do, it's 7 minus, what is that, 11 minus 9 pi over 4, which I think gives me -4.
Yeah.
And so this whole thing's going to give me a -4 plus 9 pi over 4.
So
Yes.
tell me you had to do a 9 minus 9 pi over 4?
Well, all right, do you see that we're looking for this orange shaded area?
Yeah.
And that orange shaded area is the square minus part of a circle.
Oh, okay.
And so what's the area of that square?
9,
And are you good now?
yes.
All right. And I will go ahead and tell you this is the hardest version of this type of question I've ever seen. All right. A lot of times normally they're combining two ideas. This idea of you take a big area and break it into two little parts, they do that frequently. Finding the net change from a picture, they do that frequently. I think this is the first time where I've seen them combine both of those ideas in one question. All right, are we okay with A? All right, so now let's look at B. Oh, shoot, shouldn't have done that. Okay, so you are asked to evaluate what's the integral from 3 to 5 of 2f prime of x, actually, plus 4. Okay, please pay attention to this. This is something they ask on multiple, they used to ask this a ton on the multiple choice. Now they've, apparently in 2019, it's, now a free response question. This is not a hard question. I want to make sure you get it right. Got it? So when you see this, first we're going to break this apart. This is the exact same thing as, I want to say this is the integral from 3 to 5 of f prime of x. I'm going to pull the 2 outside plus the integral from 3 to 5 of 4. And there's 3 x's there. Does everybody see how I broke it apart? That's not an exponent. That's just a 4. So now, let's answer the easy parts. Do you know what this is describing?
The first one?
What I circled. Do you know what that's describing? Does everybody understand that's a rectangle? If it says, what's the integral from 3 to 5 of 4, this is describing this picture. You're at height 4, and what's the area from 3 to 5? Does everybody see that's a picture of a rectangle?
Yeah.
And so the picture of that rectangle, that's an 8. You okay with that? Now, and this is kind of my fault because we didn't practice a lot of these. What is the integral of f prime? Are we okay? The integral of f prime is f? So when you take the integral of this is the same thing as f of x evaluated from 3 to 5, all that times 2. Does everybody understand how I went from here to here? If you take the integral of f prime, you're going to get f, and I want to evaluate that from 3 to 5.
And would that be the same as f5 minus f3?
That's exactly what it is. Does everybody understand that? And so now this is going to be, here, I just need the board. I hate having limited space. And so this is going to be 2 times f of 5 minus f of 3. Actually, let me put it over here. So 2 times f of 5. All right. Okay. So, what's f of 5?
0.
This is f. Is everybody okay? F of 5 is 0? Right? So this is going to be 2 times 0 plus, what's f of 3?
3 minus root 5.
Does everybody see f of 3 is 3 minus root 5? And so this is 3 minus root 5.
Wait, why would you plus not minus?
What?
You're evaluating
Oh, whoa, whoa.
5, right?
F of 5 minus f of 3. Thank you, sorry.
Can you explain how it's 3 minus 3?
So f of 3 is, when you plug in 3, what's this y value? See how they give you a dot?
Very good.
everybody see that part? So, when I work this out, what's that going to give me? It's like negative,
Negative 3 plus root 5 times 2.
well, negative 6
Negative 6
plus 2 root 5.
plus 2 root 5.
So this is negative 6 plus 2 root 5. And so this is negative 6 plus 2 root 5. This was an 8, so I get a plus 8. So my answer is going to be 2 plus 2 root 5. Everybody see how that worked? All right? Takeaways from this. Anytime you take the integral of a constant, remember that's an area of a rectangle. And when they ask what's the integral of the derivative, right, this is going to show up. If you see the integral of f prime, okay, that's just going to be f evaluated from 3 to 5. Is everybody okay? Part C, and this I need to talk about. If you can, put like a star by part C, because this is something that they ask every year in a free response question. Usually it's not in this type of free response question, it's usually in something else, but I want to make sure we understand how to deal with it. All right? The function blah is given, so we've got g is the area from negative 2 to f of x. It says find the absolute maximum value of g on the interval negative 2 to 5 and justify your answer. All right, whenever they ask you to find the absolute max or absolute min, what are they doing?
Looking at n-base.
What? No, well, you can use the second, but not in this one's case so far. But this is a first derivative test, right? Do you see these are optimization problems? All right, anytime, and they ask for absolute max or absolute min, you are concerned with, right, think of G as a graph. Is everybody okay that G has a graph? It's doing stuff, has some waves. We are looking for, in this case, what's the highest value? Now that highest value could happen in the middle. So let's say my graph looks like this. Do you see how the maximum could be here? Or it could happen at an endpoint. So anytime you're asked for an absolute max or absolute min, your job is you need to find out where your critical values are, and then you also have to check your endpoints. Got it? So here is the work for part C. So for part C, I have x and I have g. And I want to find out different values. At first, I'm concerned about my endpoints. So what's one endpoint?
Negative 2.
And what's the other endpoint?
5.
5. Are we okay? We've got negative 2 and we've got 5? And so we need to compute what's the value of g at negative 2, what's the value of g at 5. Those are actually pretty easy. They're actually really easy based on what we've done. What's the value at negative 2?
0.
Is everybody okay from negative 2 to negative 2? You haven't gone anywhere, so your value of g is 0? And what's our value at 5?
Negative 4 plus 9 pi.
Are we okay that from if I want to know what's my value at 5, then that's, so we have g is defined as the integral from negative 2 to x of f of x. So if I want to know here, I want to know what's that cumulative area from here to here. Right? And so my cumulative area from here to here, we've actually already done, haven't we? It ends up being, this spot. And what was that value?
Negative 4 plus 9 pi 4.
Is that right?
Wait, no, that was, I think.
It's 9.
I thought it was 9. Well, I think it's 11 minus.
Yeah, 11 minus 9.
I think it's 11 minus
Oh,
9 pi over 4.
I did that math there.
Oh, yeah, 11 minutes.
If you want to relive that, remember this was a 2, and then we have So this was 2, and then it was 9 minus 9 pi over 4, and so that's where we get the 11 minus 9 pi over 4.
Yeah, I was looking at the answer.
Okay.
But I know.
So, is everybody okay with those are our endpoints? Okay, how do I find values in the middle?
Look at the slope of that.
You're looking for critical values, right? How do you find critical values?
5 spots.
With a graph key.
Concave up and down.
No, those are points of inflection. How do you find critical values? What's 0?
On
On the slope.
the first, not the first.
Give me another word for slope.
On the derivative.
When the derivative is 0. All right? You don't know what the slope of g is from here.
Yeah.
Well, you do a little bit, but what, so, does everybody understand when we're looking for absolute max or absolute min, you need your critical values. I care about where g prime is equal to 0. And if g is equal to the integral of f, what is g prime going to equal?
F of x.
F of x.
F of x is 0 very critical.
Does everybody see that? And so I care about where g prime is 0, where f of x is 0. Where is f of x 0?
Negative 1, 1, and 5.
Negative 1, 1/2.
1/2
Oh, 1.
and 5. Does everybody see that? So I need to find out what's going on at negative 1 and what's going on at 1/2. Does everybody see that?
Why don't you find out what's happening at 5?
I already do. I've already got it. And so now I need to compute what is my value of g at negative 1 and what is my value of g at 1/2. If this is your function and we're starting at negative 2, what's my value from here to here?
0.
1/2.
Is everybody okay? The value from here to here is 1/2? Because what's our cumulative area from negative 2 to negative 1? That's 1/2. And then I need to know what's my cumulative area from here to here. 1/4. Because these areas cancel. Actually, I think it's negative 1/4, right?
Yeah.
Negative
Are we okay? That's negative 1/4. And so this is negative 1/4. And now with this chart, which one is the absolute maximum? What's our biggest value?
G of 5. Or 5.
11 minus 9 pi over 4. Notice it asked, find the absolute maximum value. They didn't ask when did you attain your absolute max value. They said what is your absolute max value? So it's this. Your justification is this chart. All right? When they ask for absolute max or absolute min, they want a chart for the justification. Now, 90% of the time your absolute max usually happens at a critical value. Did our absolute max happen at a critical value here?
No.
No, happened at an endpoint. Do y'all see that? Which is why it's not enough just to take your derivative and set it equal to 0. Because if you set your derivative equal to 0, this actually is a local maximum. It is not the absolute maximum. All right? Everybody okay? And now we go to the tricky question. And my tricky question says, what is the limit as x approaches 1 of 10 to the x minus 3 times f prime of x all over f of x minus arc tangent x. Now I want to talk about why this is tricky. Okay? This is one of those things, 90% of the time when you see limit and you see a bunch of weird stuff, this is code for you're going to use L'Hopital's rule. 90% of the time. Anytime you see limit with weird stuff, and y'all remember what L'Hopital's rule is, where you get to take the derivative of the top and the bottom? Okay, there's a problem. For you to use L'Hopital's rule, what must happen?
You have to get an indeterminate form.
You've got to get 0 over 0. So just because you see something weird, don't automatically assume you're going to be using L'Hopital's rule. Because if I plug 1 in, when I plug 1 at the top, let's see, 10 to the 1 is 10 minus f prime of 1. What is f prime of 1?
The slope at 1.
The slope at 1. What's our slope at 1?
2.
2.
3, 4 on top.
So that's going to be 3 times 2. Last time I checked, that's not 0. Does everybody see that? And since that's not 0, we're not going to get an indeterminate form. So I'm going to end up with 4 over, and when I plug in f of 1, f of 1 is 1, minus arc tangent of 1. Here's the beauty of the way they currently grade. You didn't need to know what arctan of 1 was. This is a non-calculator question. You literally could have put down 4 over 1 minus arctangent 1, and you would have gotten full credit for this.
Wow.
And it's nice to know that that should be pi over 4. All right. This is a dense question. There are lots of ideas, right? I mean, did you notice, like, it seems like each part it had at least 2, sometimes 3 different ideas you had to know? This is a very dense question. If at all possible, I'm posting this video, look at this again. Go through the question again. All right? All right. This one was tricky too. If you're curious, the ideas they are incorporating here, they're incorporating a related rate and a differential equation problem with some chain rule and other stuff. Okay. So this one says a cylindrical barrel with diameter 2 feet contains collected rainwater as shown in the figure above. Water drains out through the valve not shown at the bottom. The rate of change of the water with respect to time is given by this. So they give me dH dt is equal to negative 1/10 square root of h, where h is measured in feet and t is measured in seconds. They give us the volume. All right. Part A isn't so bad. It says find the rate of change of the volume of the water, in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Right? Anytime you see the thing that says indicate units of measure, even if you can't come up with the right number, put the right units of measure, you get 1 point for that. All right. Do you recognize this is a related rate problem? What are the keys of this related rate problem? Well, they talk about rates, right? They tell us this, they give us dH. If you see something dt, that should set off something, oh, this is a related rate problem. What are they looking for?
The volume times
They're looking for dV dt. Does everybody see we're looking for dV dt? So, and they give us the volume. They tell us that the volume of a cylinder is pi r squared h. In this problem, does r change?
No.
Because they're talking about the water, right? The height changes. The water does the radius doesn't change. What's our radius? Your radius is 1. So when I look at that volume equation, I think this is 1 squared. So I end up with v is equal to 1 squared times h. If I'm looking for dV dt, then I take the derivative. So I end up with dV dt is equal to pi dH dt. And what do they want to know?
Rate of change of volume.
Rate of change of volume when?
Height is 4 feet.
When h is 4. So if h is 4, I need to know what dH dt is. Right? Since I need to know what dH dt is, I got to plug a 4 in here. So dH dt evaluated at 4 is going to be negative 1/10 times the square root of 4.
Negative 2/10.
So I get negative 2/10. So dv dt is equal to pi times a negative 1/5. So negative 1/5 pi.
So we didn't make our chart.
No. Well, there were only 2 letters. I lost a point. What did I forget?
Units.
Units. What are my units?
Feet per second.
Feet cubed,
Feet cubed. Why?
because it's volume.
Because it's volume. dV, right? It's volume. So this is going to be cubic feet per second. If it was area, you'd say feet squared. But do you see it? If it was height, we'd just say feet.
Pi over 5, and that's
Yeah.
feet cubed per second.
Yep. All right. Mean question. But they've been mean on these. When the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing? All right. If they ask, is the height increasing or decreasing, you look at the derivative of the height function. If they ask, is the rate of the height increasing or decreasing, do you see we need to look at the derivative of dH dt? Anytime they ask, is something increasing or decreasing, that means take the derivative of whatever they're asking about. Does everybody understand that part? That's a very, very important idea. It was this, they asked something very similar actually in question 1. But it's asked, is the rate of change increasing? So the rate of change is this. And if I want to know if that's increasing or not, I need to take the derivative of this. So our derivative of this is going to be d2h dt, and then I have to use implicit differentiation, so I end up with negative 1/10 times the derivative of that, which is going to be times 1/2 h to the negative 1/2 times dH dt. Which, let's see, if I clear this up, that's going to give me negative 1 over 20. I'll put the square root of h. But what does dH dt equal? Does everybody see dH dt is this? So let me make that a little more legible. dH dt, I've got to replace dH dt with this thing. So I end up with negative 1/10 square root of h. What happens?
25.
The H is counted.
The h's cancel, the negatives cancel, I end up with 1 over 200. All right, so what's my answer? It's increasing because its derivative is positive. Tricky. Okay. All right, part C. At time t equals 0, the height of the water is 5 feet. Using separation of variables, find the expression for h in terms of t. Everybody recognize that's a differential equation? Right? And since we recognize that's a differential equation, we're going to separate the variables, which means, because the dH is on top, I want the h's on the left, I want the t's on the right. So when I start, I'm going to have, what's this? dH over the square root of h is equal to negative 1 over 10 dt.
Wait, hold on.
I divided by square root of h and I multiplied by dt.
Yeah.
Now, for the way I want you to think about this, think of your h's as y's and your t's as x's.
Okay.
So now we take the integral. this is going to give me negative 1 over 10 t plus some constant. This ends up giving me, all right, just, I need to go through it quickly, ends up giving me 2 square root of h. Sorry, I went through it quick. My claim is if you take the derivative of this, you get this. Got it? All right, well, we have not solved our differential equation. I have to solve for h. So one, I'm going to divide, I'm going to multiply everything by 1/2. So if I multiply everything by 1/2, then I end up with the square root of h. This is going to give me a negative 1 over 20t, and then 1/2 times c is still c. At this point, I'm going to try to figure out what c is. We can do it later, but it actually is faster here. Notice they give me a coordinate. They give me a coordinate t equals 0, the height of the water is 5. So they give me the coordinate 0, 5. Which means I plug this in for t. Here's your t, here's your h. So I end up with square root of 5 is equal to negative 1 over 20 times 0 plus c. Well, that makes it pretty easy to figure out what c is. So c is equal to the square root of 5. So now I'm looking at the square root of h is equal to negative 1 over 20t plus the square root of 5, which means h is equal to negative 1 over 20t plus the square root of 5 squared. So you will get a differential equation. Sometimes it involves natural log. In recent years, it hasn't. Everybody okay with this? All right. Now, question 5.
How do you know it was squared? Where did the square come from?
Where did this square come from?
Yeah.
I had to solve for h,
Uh,
so I had to square both sides. Yay! We get their old solids, right? And then it's like, yuck. This, when I first looked at this, that seemed that to me seemed a little ugly. It says find the region R. Well, fine, I'll find region R. So for part A, that's going to be the integral from where to where? That part's easy, right? And then if I do top minus bottom, which is the top function? This, right?
Yeah, h.
Yeah, h. So that's going to give us 6 minus 2x minus 1 squared minus this thing, which is negative 2 plus 3 cosine pi over 2x. I think the good news is I actually think you get 1 point for this, for that part. So now you get to take the integral of all this. I'm going to clean it up just a little bit.
Can you use this calculator?
No.
Yeah.
So if I clean this up a little bit, that's a minus, that's a big fat plus. So this is the integral. That's why I haven't been using blue. I need a new marker. This is the integral from 0 to 2 of 8 minus 2x minus 1 squared minus 3 cosine pi over 2x. And what's that going to give me? 8x. I think it's going to give me minus 2x minus 1 cubed over 3 minus, I think that's 6 over pi sine of pi over 2x dx. Evaluated from 0 to 2. And I don't know. Can you all take my word for what the answer is?
Yeah. You're posting this video, right?
Yes, I am posting this video. It ends up being, after you plug a 2 in, you've got to be careful with the 0. But as far as the computation comes, I got 16 minus 4 pi over 3. Make 16 minus 4 over 3 for the answer. And you have to be a little bit careful, right? I did want to get to part B, because part B is an easy question if you understand what it's asking. And you may not, I need to make sure we understand what it's asking. Okay, region R is the base of a solid. For the solid at each of the x cross-sections perpendicular to the x-axis, it has an area of 1 over x plus 3. Find the volume of the solid. All right. So does this look like your growing stuff? Anytime you see cross-sections of your growing stuff? And what they've realized is that there are a bunch of teachers like me that said, hey, these are the 7 shapes you need to know, right? Find the area, right? Notice every one of those things you found the area. Here's the trick. They gave you the area. Do you see that? This is the area. And what you're trying to do when you want to do volumes with known cross-sections, first, okay, so part B, where am I stacking the rectangle from where to where? Are we okay? We're stacking the rectangle from 0 to 2. Everybody got that? And then what goes here is the area. Now, all the problems that we did, your area had to do with S, wasn't it? Where you figured out what S was, and that had something to do with your rectangle, and you squared it, or you did other stuff. But they told us the area. So guess what I put here? I put the area, which is 1 over x plus 3. All right, that's really sneaky. Because you're so used to, like your area is, it's in terms of S. Like all of your other areas, like if I said the area of an equilateral triangle, you said that was square root of 3 over 4 times S squared, and S was something. And so this was my area. What they've done here is they want to see, do you really understand what you're doing, not memorize what your teacher has told you. And so they actually tell you what the area is. Well, if this is your question, that's not hard. In fact, they actually find this, that's not hard. The integral of this is going to be natural log of x plus 3, evaluated from 0 to 2, so end up with natural log of 5 minus natural log of 3, and there's your answer.
So, that's the base solid. Base solid.
What?
Interesting.
Okay. Part C. And this is pretty comparable to, I think this is like the only standard question they've asked so far out of all the free response questions we've got. Write but do not evaluate an integral expression that gives the volume when it's rotated around the line y equals 6. And so our big radius is going to be 6 minus, so it's going to be 6 minus this thing, which is g of x. And your little circle is going to be 6 minus h of x squared, and we're going to stack our rectangles from 0 to 2. That kind of makes sense? All right? And